And welcome to the Daily Space Weather. If you're getting your space weather elsewhere, you just aren't getting the full story. So here we go. Starting out with the T-mass, the most active sunspot. It's sunspot 3536 once again, the producer of the largest solar flare during solar cycle 25 to date. It did produce an M-class flare in this 24-hour video. Here's the equatorial zoom. And there were some more coronal mass ejections to cover. Will they be earthly directed? We'll let you know later in the video. This is, by the way, 304 angstroms raw imagery along with the 131 angstroms 60-minute running difference. There is the full disk view, and we've got some new sunspots that just rose over the southeastern limb. Also some other assorted sunspot growth, and a big uptick in the sunspot number as we forecasted yesterday. Next, we'll look at the SDO continuum for a brief moment here. So some growth down there in the southwest. We've got a huge uptick in the likelihood of large solar flares here. So we've got a likelihood of large solar flares in the southwest, the southeast, and of course from sunspot 3536, which is again this sunspot group right here. It is still quite magnetically complex, and there is the SDO colorized magnetogram for today, January 4th. And by the way, if you enjoy the content, don't forget to press the like button. Tell your friends and foes about the channel. Again, if you're getting your space weather anyplace else, you are missing out. If you're new to the channel, press subscribe. Congratulations on realizing the channel exists. And here is a brief rundown of the volcanic activity that's currently going on. So, quite a few active volcanoes here. That is the list. I don't feel like reading them all out, but there they are scrolling across your screen. Keep in mind our channel has about a high school physics level of prerequisite requirements, so if you're unable to read, you're probably not qualified to watch the videos anyway. So anyway, that's what's going on. Here's the volcanic map. The minor and currently erupting volcanoes both shown there. And let's take a look at what's going on as far as seismic activity there in the past 90 days. Again, courtesy of volcanodiscovery.com. And let's move to the USGS map to cite quakes of a 5 and greater magnitude. Band AC had a 5.0. It was at depth over 117 kilometers estimated depth. Tonga had a deep quake as well, a 5.6 at 187 kilometers estimated depth. Japan had a 5.1. That was closer to the surface at 10 kilometers. As aftershocks continue in northern Japan. After that, a long lull with no 5 magnitude or greater earthquakes. That's where the list ends. And let's get back to space. Here's another 24-hour video for you. The 304 angstroms 60-minute running difference along with 193 angstroms. So again, there was a CME. I believe it came from this sunspot 3536 earlier this morning. Quite early this morning. And like I said earlier, we have some new sunspots that just rose down there in the southeast. So again, flare likelihood has gone up as a result of that. And let's move to some stats. The 10.7 centimeter radial flux is only at 126 solar flux units. You can expect an uptick for that coming in tomorrow's Daily Space Weather video. And, oh man, sup with that. And there is the 1-year graph of the radial flux, depicted by the black line. The red line is the sunspot number. The blue line is the Potsdam AP, which is similar to the KP index. It's like an average of the KP index. It's an average of global geomagnetism. Moving right along to the Space Weather Enthusiast dashboard. And NOAA is not forecasting any geomagnetic unrest or geomagnetic storms. Now, if you watched yesterday's Daily Space Weather video, we actually forecasted a minor CME impact coming. Watch yesterday's video to find out when we forecasted it for. We do them daily, not to be redundant. Anyway, yeah, here's NOAA's Enlil spiral, and they're not forecasting any CME impact. So, them's the breaks. You be the judge. We show the data and let you decide. So we don't tell you what to think. we show you how to think. There's NASA's Enlil spiral, and NASA is showing that CME missing Earth as well. So there you go. NASA and NOAA's forecast once again disagreeing with us. So we'll have to see what happens there. And let's move on to Earth's magnetic moment from space. So there's Earth's magnetic moment, modeled by the Space Weather Modeling Framework out to about 12 Earth diameters. The approximate size of Earth's magnetosphere. Did you know that Jupiter's magnetosphere is so huge that if it were visible to the naked eye, it would be like the size of the full moon? Here are the last 4 hours of Earth's magnetic moment from the ground level. Another feature of the Space Weather Modeling Framework, it's our geospace ground magnetic perturbations map. And there should be some aurora visible in the normal suspected hotspots. So there you go. Next we'll move on to the KP index, which is at 1. A solidly geomagnetically calm condition. KP1 is the current average of global geomagnetism. Next we'll look at some real-time solar wind data. There's the ACE missing a ton of data once again, showing a pretty diffuse and pretty nominal solar wind there. Not very exciting. Discover not missing so much data. So let's call out the numbers on that. Current solar wind density is about 4 protons per cubic centimeter. The heck? Solar wind velocity here a little bit faster at 417 kilometers per second. Goes magnetometers here looking smooth. No space weather storms in the past 3 days. Next, our top view ecliptic plane field plot, one of my favorites, and one of the best features for predictive value, part of the Gong 2 data, the National Solar Observatory. And Earth remains in a North Pole sector, a sector of North Pole heliospheric magnetism, shown there in green. And next, let's move to the line of sight field plot. Gotta love the line of sight field plot as well if you're a solar science nerd. The B field depicted there, the photosphere magnetism, as well as the polar fields. And that does depict the past 4 days. That brings us to coronal holes. And we're seeing the uptick in coronal holes exactly as we forecasted. There you go. The line of sight coronal hole plot. And next we'll take a look at coronal holes from SDO. So there you go. And we basically have it pretty even split here. These are North Pole oriented. These are South Pole oriented. And let's get the sunspots. Sunspots, the number has risen up to about 108. 108 sunspots. That is the sunspot number from Rob, the Royal Observatory of Belgium. Next, our flare probability monitor and scoreboard. And like I said earlier, we have a possibility of large solar flares from 3534, 3536, and especially these new sunspot groups in the southeast. So those look like they're capable of producing large flares to me. It's a little bit early to guess, but their proximity to the limb and apparent magnetic complexity are dead giveaways. So those are the places to expect large solar flares. And let's move on to our continuum imagery from Solar Dynamics Observatory. And let's show an extreme close-up here. There you go. That is where the most sunspots are, in that northeastern quadrant. Great scale there to show you how large those sunspots indeed are. And let's move to energetic particles and solar flares. Proton flux here, we pulled up the 7-day graph to show you it looks like this minor proton event storm has reached its peak and now started to decline back down. Keep in mind, folks, we might see additional spikes in the proton flux because we have a magnetic channel opened up between the Earth and Sun right now. So if we do see a major flare, the likelihood of seeing additional proton flux events, or SEPs, solar energetic particle events, is certainly there. So don't be surprised to see additional solar energetic particle events. So we should see the polar radio blackouts starting to subside here by the end of this video. This represents the attenuation of the D layer of the ionosphere. So if you see around the equator, that's the actual solar X-ray output. The deabsorption around the polar regions, that is from radiation associated with those solar energetic particle events. So SEPs cause polar radio blackouts. Solar flares cause equatorial radio blackouts. And again, we do see this subsiding here toward the end. I'm just going to rock this forward. Here's a decent flare from this morning. Actually, that's this afternoon. And there you can see a little bit of a subsiding, especially in the north polar radio blackouts. Still some brownouts occurring in the north polar region, and significant radio blackouts in the southern polar region. So there is our X-ray flux. Largest flare of the past 24 was an M4 approximately, M3.88. And let's look at flares from SDO. Here is the SDO 131 angstroms 60-minute running difference along with 94 angstroms. Here's just 94 angstroms, raw data. Great view of that M-class flare early this morning. And here's 131 angstroms by itself. A very bubble-like solar flare there. Quite a homogeneous event. And let's take a look at a star chart next as we orient ourselves. So that's what's going on overhead. We've got the largest planet there moving from Aries into Pisces. I think it's in Aries. I don't know. Saturn is in Aquarius, which means a thing to somebody. I don't know. It means like make sure you update your diary today or something, or go swimming in the ocean after jumping in a sauna, or I don't know, something. It means some kind of a thing to somebody. And here comes the forecast for the solar system. So this is where heavenly bodies are today. That's where they'll be in a week as we approach the new moon, which looks like it'll fall on the 12th of January, the first full moon of the year 2024. And next, the astronomy photo of the day. So this is an awesome image from the Spitzer Space Telescope. It's showing a bow shock for a bright, rowdy star. A star that's like 65,000 times as bright and active as the sun. And this is the bow shock that we're talking about. As this star blasts through the galaxy, it's illuminating the dust that's around it. This would be one of the brighter stars in the sky had it not been surrounded by so much dust. But it's pretty dusty there. So the star is known as Zeta Ophiuchus. And again, it is about 65,000 times as bright as the sun. It's a rowdy blue giant. So very significant stellar wind from that star. Zeta Ophiuchus is the astronomy photo of the day, exhibiting an awesome bow shock and some filamentary features there you can see in that dust that it is illuminating. Hopefully that was illuminating. And it's time for CMEs. So here are, let's move to yesterday's CMEs. So those are yesterday's events. That's 104 frames from yesterday. Again, see yesterday's daily space weather video for what I thought of it. Here are today's frames, 93 more frames from today. So early in the morning, you can see a CME coming out of the northeast there, which would be your upper left. And that one, I think, has an earthly directed component once again. So expect the arrival of that one on the 7th. So 2 CMEs are on the way. And we paused this one here at 0 dark 48 because that's about when you see that happening. You can see a partial halo there as that CME pops off from the northeast. So that is looking like it's earthly directed, or at least containing an earthly directed component. And we're going to let C3 catch up with C2 here and then let those play through before we show you our custom coronagraphs. So some additional events happening later in the day. I don't think those have earthly directed components, but that one popping off early looks like it did. Now there's an interesting one out of the southeast as well. And we'll also take a look at that here. Let's take a look at our custom coronagraphs. There are some 24-hour videos, and you can see that comet that we covered yesterday, and it is gone. It has evaporated. So another prime example of a self-destructing comet there as it encounters a little bit too much solar wind for it to continue to exist. That's SDO 193 angstroms in the center. Another 24-hour video syncing up all of those coronagraphs and SDO imagery. So right at the beginning, you'll see a CME. I do believe it came from this group right here. And I think there is an earthly directed component. Here we'll drop the C3 and add the 304 angstroms running difference of 60 minutes to the 193 angstroms SDO imagery. Yep, looks like a couple of CMEs on the way. The impacts of those will be minor. We expect the KP index to stay below 6 from both of those, as they are not directly headed toward Earth, and they're a little bit on the diffuse side. Here we'll get in a little bit closer and show you the full disk view by itself. No coronagraphs. And yeah, that CME came from this area right here, the area just to the southeast of sunspot 3536. And let's get back to filaments. So here we are at filaments, the ground-based Cerro Tololo, Chile solar observatory there, and some prominences showing up there in the southeastern limb, along with those new sunspots down there. So that's always exciting. Here's the colorized imagery. Yeah, so the flare watch has actually gone up here. So the likelihood of a large solar flare has been increasing over the past about 24 to 36 hours. I'm always delighted to say that because bring on the space weather. And before we get the bonus features, here we've decided to bring up the 284 angstroms wavelength from the GOES 16 SUVI, just to show something different. There's no major stuff going on right now. We usually show 304 angstroms. So some wavelengths not visible from the SDO. The SDO doesn't cover 284 angstroms, but the GOES 16 SUVI does. So it's great at showing active regions and the extended corona there. And let's move to bonus features. Bonus features. They used to be separate videos, and now they're the same video. You can ask YouTube about why that is. First bonus feature is charging hazards. We don't have any. It's smooth sailing. No high-energy electrons building up inside of spacecraft. No low-energy electrons building up outside of spacecraft. GOES electron flux here. There you go. That's the past 3 days. It's in a kind of a low operating range there. There's the one-year graph to contextualize it. Low levels of electron flux at the moment. And NOAA is expecting an uptick. I would tend to agree. The green boxes are the forecast. The yellow diamonds are the observation. Next, the ionosphere. How about that F-flare? That F&F flare. Well, there it is at 300 kilometers of altitude. And here it is in vibrational frequency, courtesy of the Australian Government Bureau of Meteorology. Ionosphere looking normal and healthy to me. Pardon our lack of forecasting the apocalypse. To quote Carl Sagan, extraordinary evidence is required for your extraordinary claims. I'm sorry, let me try that again. To quote Carl Sagan, extraordinary claims require extraordinary evidence. And here's another tidbit for you folks. If your hypothesis is refuted by all available data, abandon that hypothesis because it's gonna be wrong. Next, the whole atmosphere model, the global ionosphere nowcast. Total electron content on the left, maximum usable frequency on the right, along with the anomaly for both. That is the ionosphere, and we'll close out space weather with the latest high-res images. So we're going to show you those new sunspots first. I'm excited. And there you go. That farther north one, that is indeed a magnetically complex sunspot group. And now let's show the prime suspect for major solar flare, sunspot 3536. So that remains the most likely place for large solar flares. It looks like it has degraded a little bit since this morning, but guess what? It is still Beta Gamma Delta class. And let's move on to meteorology, which also used to be a separate video, but now is the same video. Because again, we didn't want to see our views reduced by YouTube's bizarre, nonsensical algorithms, so we put all the videos together. And now we release shorts instead, and we're fine with that. We're starting out meteorology by looking at Saharan dust. And there's a bit of Saharan dust there making its way across the Atlantic. We haven't shown it for a while, so there you go. There's the dust scenario. It's showing surface winds and dust. Optical thickness of 550 nanometers. So very, very fine dust. Anyway, here come our regularly scheduled meteorology portions of the video. Surface winds of the east, jet streams of the east, jet streams of the central world, surface winds of Africa, Europe, and the Middle East. Strong low here forming in the southern Indian Ocean. Surface winds of the west, jet streams for the Americas, clouds and fog over the Americas. Our meteorology segments are value-added services. We bring you the weather from space all the way down to your place, especially if you live in the lower 48. Check it out. We got a low making its way across New Mexico at the moment. Actually, I'm sorry, making its way across Arizona into New Mexico at the moment. See that counterclockwise rotating system there making its way toward eastern New Mexico. And next, our windy.com map to look at snow for the next 3 days, and we are getting snow in Pennsylvania. 3 to 6 inches are in the forecast for Lehigh Valley. Anyway, there is the full 48 states view. That's the Euro model. And the GFS model is showing lighter snow for us, heavier snow for central Pennsylvania. So there's the GFS model. That's new snow for the next 3 days. There's the Euro model, new snow for the next 3 days. Here come the weather.gov forecasts. And a winter weather advisory stretching all the way from North Carolina. Winter storm watch stretching from North Carolina all the way up into New England. So there you go. If your location's lit, head to weather.gov and click your location. Here comes some forecasts for you, courtesy of Tropical Tidbits. Go say hi to Levi Cohen over there on Twitter if you like. TropicalTidbits.com is where we get our forecasts if you want to make your own awesome GIFs. just like ours, then tropicaltidbits.com is highly recommended. Like we've been saying for a couple of days here, some heavy weather about to form around the Texas-Louisiana border and make its way across the Gulf states. There's going to be some severe weather down there for all you Gulf state viewers. Take heed of that. Could kick up things like damaging wind and hail. Even tornadoes could be generated by that system. Also some significant snow coming, so we'll cover that as well. Excited about it. Here comes the GFS accumulated positive snow depth change in inches. Ta-da! So quite a bit of snow here. Most of the country will be blanketed by Sunday. Nice. Next, our GFS total accumulated precipitation forecast in inches. In Louisiana, the Florida Panhandle, and parts of Alabama there, expecting some significant rains. At least more than 2 inches in a lot of those areas. We'll also show the temperature anomaly forecast in degrees Celsius. By the way, all these forecasts are GFS 72-hour forecasts. Some very cold weather coming to California, Nevada, the western portion of the country in general. Also, Mexico is going to see some temperatures about 16 degrees Celsius below normal. And let's next show the forecast for the culprit. So this is what is allowing all this cold air to make its way so far south. The jet stream is really far south, and it's starting to reach a more of a normal mode here in the next 3 days. So things will get a little bit more average for us here in the coming 3 days. There'll be a strengthening of the jet stream in the southern portion of the southern Mississippi Valley, really. And then things are going to start to get a little bit more normal there. The 72-hour GFS 250 millibar forecast is what we're showing. We'll also show lightning. That's the past 10 hours or so. Not too active there. Here's a real-time lightning map from lightningmaps.org. The Atlantic Ocean there is the lightning capital of the world right now, but we only have 3.1 strikes per minute. It's a pretty low level of lightning. We'll close out the video with U.S. Doppler radar, clouds and fog, and water vapor. The 3 definitive things to look at if you'd like to be able to forecast your weather. So I talked about it last night with Smash staff. Here's something we got to bring up a little bit more often. How the weather really works. So this is 3.9 micrometer infrared radiation, part of the shortwave infrared spectrum. And that shows clouds and fog at night. That can be useful if you're interested in being able to see a meteor shower or the aurora, perhaps. But really the most definitive map, in my opinion, is the water vapor map. So it's important to understand that this air right here is going to be more massive than this air over here. Even if this is at the same temperature, this air here, this moist air, will be less massive than this dry air. So if you've ever noticed that on a dry, clear, windy, blustery day, the pressure is the highest, that's because of the molecular mass of atmospheric nitrogen versus water vapor. Water vapor is less massive. That is why a hurricane has low pressure. And a clear, windy, cloudless day has high pressure. The less water you have in the atmosphere, the more massive the air is, and hence the higher the pressure. Anyway, that's the way things really work. The high pressure kind of runs the show. It pushes the low pressure around in many ways. The low pressure sucks, the high pressure blows. There's your recap. U.S. Doppler radar. Impress your friends and foes by being able to forecast the weather with extreme precision in your locality. Press the like button. Press share. Tell your friends and foes, lest thy soul be cast into an ever-deepening and darkening abyss, perhaps a tributary of the river Styx. That's clouds and fog, and here's water vapor, and it's time to close this thing out. Once again, thanks for tuning in, folks. Congratulations on realizing the Smash News Network least busted name and news exists. Thanks to our new subscribers. We'll see you soon, and in the meantime, may that solar wind be at your back.